Guys, all right, so if you are watching this video, then you are prepping to review for the test on univariate data, all right? And so with that, without further ado, I'm just going to dive in. So the plan is that this video is going to cover all the different questions, or at least as many of them as possible, and explain a bit on how you do those. That way, if you had a question like, hey, how do I do this problem? Hopefully this video will answer that question. All right, that's the goal. All right, if we're living right. So without further ado, we're starting off with a problem that asks you to complete a frequency table. So as a reminder, that is basically just a fancy way to say that it's a table that tallies, and by tallies I mean shows the count of data in groups or classes, okay? And just as another little piece of info, this type of table would create, or like could be used to create, a histogram, okay? So you kind of need a frequency table in order to have, create a histogram, okay? It's like they're connected, more or less. So with that, the thing I wanted to just remind you of is that whenever you see the square bracket, remember you want to be like equal to, like, or include that value. But when you see the parenthesis, although I guess for all of these they're going to go this way, remember that means do not include. Okay, so this part is pretty boring, but I'm just going to remind you. So like, for example, and when I say boring, I shouldn't say that. Math is super fun, guys. Okay, but this is just more of like you just have to analyze each value, right? So like 30 is in between 26 and 31, so I make a tally. 32 is in between 31 and 36. 11 is 11, right between 11 and 16. But like, okay, see this number 16? That would be tallied here in the second row because 16 is included in the second row because that's where it's equal to, okay? So if you are living right, if you do this problem correctly, you should end up with 1, 2, 3, 4, 5, 6, 7, 8. 8 tallies for the first bin of values. You should end up with 3 tallies for the next one. There are actually none. There are no numbers between 21 and 26, so 0. Then 1, 2, 3, 4 values in between 26 and 31. Then 2 values in between 31 and 36. And then 5, I believe it's 6 between 36 and 41. Okay, so if you did all your math right, those should be the answers you got. All right, moving on. What are the and I know this probably sounds super long-winded. What are observations that stand apart from the overall pattern of distribution called, we have a much shorter word for that, outliers. That's what they're called. They're values that like don't fit the pattern. All right, and then if we were trying to describe the skew, first off, this is not symmetric, guys. Don't even try to act like this has symmetry, all right? There's this huge tail over here on the right side, and so that means we are skewed right, okay? Just remember that. Whatever way the tail goes, so the tail points at the skew, okay? All right, next problem that we're going to take a look at. So you've been given a set of data, all right? Now, I'm not going to go through the whole process, but the calculator process. What I'm going to remind you of is if you're given a data, see how this says that you're looking at box and whisker plots? Here's what you need to remember. The box and whisker plot is made using the 5-number summary. So if you want to figure out which box and whisker plot matches, then what you need to do is you need to enter this list into L1, and remember, you get to L1 by going stat, edit. All right, if you want to see where that is, The thing is, on my iPad, my calculator looks a bit different than yours. So just like keep that in mind. But at any rate, you hit stat and then the top option of edit. So then here's, my L1, which has a different list of numbers in it, but I would just, type over that with 10 and 8 and 9, etc. Okay? And then that's your first step, enter the data. And remember, your second step is stat calc. And remember, you want the one variable statistics package, okay? So that's stat arrow over 1 to calculate, and then one variable statistics. Hopefully you feel like, yeah, Mrs. Fry, I don't even know why you went over that. We've done it so many times. So here are some values that I'm going to pull from that. Specifically the median, which is 16, and the quartile 3 value, which is 20. Because I noticed that all of these have the same min, or pretty much ish. I guess they don't. I thought they did. Anyway, sorry, I'm having a little side chatter with myself. But D is definitely out because its minimum is not correct. All right. And then, because it's at 5, 6, 7, 8, it's at 9, and our minimum is actually 8. All right. And then A is out because its median is off. And so the correct answer here is actually C, all right, because it has the right minimum, the right Q1, 16 for our median, and 20 for our Q3, and then 22 for our max, okay? So we're just matching up what goes. All right, moving along. So we have another box and whisker plot, no data attached, just the box and whisker plot itself, right? So we've got to use this to answer some questions. Now, it says, according to the diagram, what is the median? All right, well, this is requiring you to be able to read the box and whisker plot and look at which section is which. So as a reminder, the middle part is the median, okay, and that pretty much looks like it's pointing at 75. So let's go with A as our answer choice on that. All right, and then according to the diagram shown, what score represents the first quartile? Okay, now remember, that's in our calculator, that would be the Q1 value, but just on our visual, sorry, meant to use my highlighter. Remember, that's just this line right here where that like first tail ends and that box starts, okay? So it's where the box meets the whisker, and so that's 70. All right, so that means our answer here will be B. Okay, what statement is not true about the box and whisker plot shown? Okay, so basically this question is asking you to analyze the information in the box and whisker plot and also demonstrate that you know what information is in the box and whisker plot. So the Q3 value, that one's correct. 55 being the minimum, that's correct. 100 representing the max, yep, that's correct. But here's what really gets you, and this question is here to make sure you understand the difference between these two words. A lot of people mix up median and mean because they both tend to fall around the middle, okay? But the mean isn't even in this picture, so that's why A is false, or like not true. A score of 85 on the box and whisker plot shown refers to, well, as we've already discussed, the third quartile value, so that's A. All right, moving along. Based on the graph of, we've got team results in a 200-meter relay. Based on the bar graph above, which of the following conclusions is most accurate? Okay, so this can be a little tricky because you might think that there's more than one right answer. No, there is a best answer. So let me read through these for you. The first place team was twice as fast as the fourth place team. So this is their speeds, right? This is how fast they were going. This says they were going 7.5 miles per second. And this says fourth place was going maybe like 4.5 miles per second. Okay. Twice as fast, 4.5 times 2 would be 9. So that's just not true. The fastest time for the 200-meter relay is 7 meters per second. The fastest time, well, see, and here's the thing. This is more like the fastest speed. So, like, I don't even know that this is true on the base of this word time. But still, the first place team went 7.5 meters. So again, it's also wrong. So B can't be true. And then C says the first place and second place teams were closest in time to one another. Okay, these were 0.5 apart. These are 1 apart. And these guys are 1.5 apart. So that seems true. All right, every runner on the first place team ran faster than the runners on the second place team. Okay, here's the deal. We just don't know. Okay, it's a team. This is just the average of the whole team. So it's possible somebody on the second place team ran faster than one of the people in the relay. We just don't know. We don't have not enough info to say that that's true. So that is why we are going to go with C as our correct answer choice. Okay? So hopefully you're feeling like this is making sense so far. All right, now we're flipping over. Let's take a look at the pie chart. All right, so we are being told that we've got the Statistical Bureau, Data Bureau, publishing an analysis on incomes of the 100 average families. The circle graph, and I don't know why this says circle. It should say pie. Graph below represents the Rosen family's monthly budget, okay? If their total income's $1,820, how much money do they spend each month on food? Okay. So if this is their total is $1,820 and food is 30%, well, we're going to change that to be 0.3. All right, and then we're going to do the calculation, and we are going to find that that value is $546. Okay? All right. Complete a stem and leaf plot for the following list of grades on a recent test. Okay, so remember that a stem and leaf plot means you have like kind of this line of data, and you're going to put the data in order. Okay, so we're going to start with the smallest, so it looks like 42. And then most likely because these are all two-digit numbers, what we're going to do is we're going to have and I guess we really don't need this line now that I'm thinking about it. We just need one line going down. We just need to show that 4 bar through it 2 equals 42% on that test, okay? And then we'll write a 5, but there are no 50% scores, so we'll just leave the space to the right of it blank. 6, and then it looks like we have 67 as a score, so we're going to use that. And then we've got a couple of scores in the 70s. We have 73, 78. Boom, boom. All right, and remember you have to try and keep those numbers in a row. Okay, then we have some scores in the 80s. We have an 82, an 84, and an 86. 82, 84, 86. And remember you want to write the scores in order. And then our last scores in the 90s are a 91, a 94, and a 99. Okay, so remember this is the key, and this part over here is the actual stem and leaf plot. All right, so at a concert, the ages of 115 people were recorded as shown in the table. Please fill in the last column with the measures of the angles. So this is really important, the angles that you'd use, okay, and we're going to round to the nearest degree. So remember that in order to figure out an angle in your pie chart, you need to take whatever percentage that data is and multiply it by 360 degrees. So it's really a little bit of unit conversion. Right now, all of these are in just like tallies, all right? This part over here is more or less a frequency table, okay? It's telling you how often those particular people occurred at this concert, okay? So what we need to do is we need to take all of these values and we need to divide them by 115. And that will get you your percentages, all right? So each one of these will become a percent. And then we're going to multiply that by 360 degrees. You don't actually need the degree symbol. I'm just letting you know that that's the units that we're working with here. Okay, so I'm going to show you one of these calculations on my calculator. Okay, so let's go to the main page. Okay, so 15 divided by 115. Okay, and then multiply that by 360. Gets me 46.95. Okay, it says round to the nearest whole degree. So we're going to go with 47 degrees. All right, I'll do one more. So the next one's 30 people divided by the total 115 people times 360. Gets me 93.9. Again, I'm going to round that up to 94. Okay? Now, if you're living right, if you're doing your calculations correctly, when you did this, you should have gotten 69 degrees, 75 degrees, and 75 degrees. Okay? And then if we do a little double check, remember that this sum should be 360 degrees. So we've got 47, 94, 69, 75, and 75. And so if you'll notice, that adds up to 360, okay? And that wouldn't happen if you rounded down every time. So remember, you just need to round appropriately. All right, so hopefully you're feeling like this is making sense so far. Now we're going to shift gears a little more into some other problems, kind of wrap up some of this content. And so I am going to pause right here and pick up with part 2. All right? See you back here if you need the help. If not, also great. Okay? Have a good one. Bye.